This type of problem, a rational equation application problem, a work for solving a work rate problem, seems to give students trouble, and I understand why it would be a little bit of a challenge. It's just a different kind of problem that you have to find a way to understand to be able to solve. Here's an example. Colin is an experienced painter and he can paint the doghouse in 3 hours. His apprentice Zachary will need 5 hours to do the same job. If they work together, how long will it take them to complete the job? Let's look at how to solve this problem. I'm going to start the problem with a chart here. So it's a chart that just gathers the information. The first problem solving step is to understand the problem. And one way to get a better understanding of the problem is to gather the information in a chart. So we can see that it takes Colin 3 hours, it takes Zachary 5 hours. And then the question is asking, if they work together, how long will it take? So I can put my X, my unknown, in this bottom column. The next step is to convert this time into a rate of work. How fast does Colin work? His work rate would be 1/3, because it would take him, or if he had 1 unit of time, so in this case hours, if he had 1 hour, he'd complete 1/3 of the job. If Zachary had 1 hour to work, he'd complete 1/5 of the job. And then we can follow the same pattern to get 1/x as a rate of work together. So that's the second step. The third step, we understand the problem by gathering the information, and then we want to devise a plan. The plan I'm going to use is sitting right here in our chart. It's here as an equation. This word together is the key word. Together is going to indicate we want to add. So Colin's rate together with Zachary's rate gives us their rate together. So here's our equation. 1/3 plus 1/5 equals 1/x. Let's write that equation out. 1/3 plus 1/5 equals 1/x. Does it look like I wrote that too big? I actually did that on purpose. When I solve a rational equation, and a rational equation is simply an equation where there are fractions and the variable falls into one of the denominators. So this is a rational equation. And when I solve a rational equation using the LCD method, I solve it by exaggerating these fraction bars like this. There is another method. You could also use the method of multiplying everything by the LCD. But I'm going to use this method. And either way, you need to determine the LCD, which is 15x. So in other words, we look at this 3, and say if we wanted the 3, 5, and x to all be identical, what would we need to factor in to the 3? We'd need to multiply in a 5 and an x, because we have a 5 here and an x here. And the goal of the problem here is, in order to add these, we need a common denominator of 15. So if we built this 5 up to a 15x, it would need a 3 and an x. And if we built this x up to a 15x, it would need a 3 and a 5. So you see, we look at this x and see, what do either of these other two denominators have that the x doesn't have? It. This first one had a 3, the second one had a 5, so we need to give this fraction a 3 and a 5. The next step is to make sure we've written each of these 3 equations with an equivalent. as an equivalent equation. We've started that by inserting the 15, but we need to then put a 15 in the numerator, a 3x in the numerator, a 5x in the numerator, so that really we've not changed the value here. What we've done is we've multiplied by 1. 5x over 5x is just 1. In our multiplicative identity of our multiplicative identity is 1, or in other words, I can multiply 1 times 1/3, the fraction 1/3, without changing the identity of 1/3. So 1/3 times 1 is just itself, and so on. So we did that with the 3x and with each of the different pieces. So now that we have written each of our fractions with a common denominator, we can solve this problem by just taking the numerators. Let me explain or show why that is. What we have here is 5x plus 3x all over 15x equals 15 over 15x. 5x plus 3x all over 15x. I did that by adding these two fractions, equals 15 over 15x. So what we have is that the denominators are the same, and if a property of fractions is if we have two fractions that we say are equivalent, so a over 10 equals b over 10, for example. What do we know about a and b? Well, we would know that a and b must be equal. So to solve our problem, our next step is going to be to take those numerators, 5x plus 3x, which is 8x, and 15 is the numerator of the other fraction, and we just state that those two are equivalent. 8x equals 15. Now it's simply a basic linear equation, so I can solve for x by dividing by 8, and I get that x equals 15 eighths. So what does that mean? 15 eighths is 1 and 875 thousandths of an hour, or we could say this is 1 hour and 7 eighths of an hour. I could convert that 7/8 of an hour to minutes, but I won't bother doing that right now. Well, I hope that this solution has helped you understand this type of problem a little bit better, and try some examples. The best way to get good at this is to practice.